Welcome to the Haven Masterclass on Mechanical Systems for Houses. My name is Mark Rosen. I'm the Director of Building Science at Building Knowledge Canada and a KC-registered Master Energy Advisor. My role at Building Knowledge is to help work with builders on the design and construction of homes that are more comfortable, more energy efficient, and more environmentally responsible and sustainable. At Building Knowledge, we recognize that building science and house as a system thinking is critical in making sure that the mechanical systems that our builders choose are well matched to the other energy efficiency measures of their homes, both in walls and windows, insulation levels, and all of the active systems that play a role in protecting your home and making it more comfortable for you for the years to come. Today's masterclass is focused on energy-efficient mechanical systems for both new and older homes that may be in need of some renovation or improvement. Mechanical systems are the active component of a home and play a very important role in improving the comfort, the health, and the sustainability of both the building and for the occupants over the lifespan of the home. As we get into these systems in more detail today, we'll touch on the four major mechanical systems of a home, which are the system that heats the air, the system that may cool the air, the ventilation air system, and also a little bit of detail on the hot water system of the home. These systems interact with and are informed by the passive elements of the home, which are the walls and windows, insulation levels, and air tightness. And the two things play back and forth in what's called house as a system interaction to make sure that all systems are balanced and performing their important roles in preserving your home and preserving the environment. As we get into these homes, we'll also talk about what systems you may look for in a new home or where you have input in your design process, and what are the opportunities in an older home to choose a good mechanical system for renovation and make sure that you're making choices that make sense in terms of sequencing for improvements to homes of different generations. Let's get into it. Mechanical systems are the active parts of your home that manage heating, cooling, ventilation, and hot water. What do I mean when I say an active system? Active systems in a home are the parts of the home, or you could think of them as the equipment components of a home, that consume a fuel or an energy source in order to perform a service or a duty. In the homes that we're familiar with, you may recognize that some of these fuel sources are either electricity, natural gas, and in some older homes and cases that are outside of cities, you might find propane or oil as energy sources as well. There are four major components of the mechanical systems of most homes. Not all are present in all cases, but let's touch on them all here. Let's start with the most familiar of these systems, which is the heating systems that we find in our homes. Heating systems are perhaps the most familiar to us because they're present in all of the homes that we build in our Canadian climate. Canada is what's known as a heating dominant climate, which means that we depend on heat throughout the year in greater amounts than we depend on other things like artificial cooling or mechanical cooling systems. And that's due to the length and the temperatures that are associated with our winter months. Even in the Lower Mainland, we find that the demands on heating systems are greater in most cases than the demands on cooling systems. And so we think of ourselves as a heating dominant climate for those reasons. Now, the most common system that you'll be familiar with for providing heat to a home would be a furnace. Natural gas furnaces have been very present in homes for a number of decades now, and perhaps second only to those would be electric baseboards, which you may be more familiar with in multi-unit housing situations or anything that has been electrically powered for its whole lifespan. Older homes may have some form of radiator that has a hot water component to it, but we'll touch on that a little bit more when we get into renovation opportunities for older homes. Now, natural gas furnaces and electric baseboards have one very important difference in that one is what's called a forced air system, which comes with ductwork, and that would be the natural gas furnace option. The furnace heats air that is moved through ductwork and distributed through the home, and that's what makes it a forced air system. And an important component of that is the fan that moves the heat out of the furnace and through the ductwork. If you contrast this to an electric baseboard solution, electric baseboards heat only the space that they are in themselves. And so an electric baseboard home may have a thermostat in more than one room because they may be linked only to the electric baseboards that are in your space. This is a naturally zoned system, and what I mean by that is that you can control the temperature of different rooms independently, which is sometimes a limitation of a more typical natural gas furnace and ductwork solution. Nowadays, you may start to hear about a more modern technology that is becoming very common in new homes especially, and in retrofit projects across the province, is the air source heat pump. An air source heat pump is a heating system that models its technology on air conditioners. And in fact, some people prefer to think of them as a heating air conditioner because it uses the same technology in reverse. We'll dive into the technology of heat pumps in a little bit more detail in a future chapter, but at a high level, the main difference between a heat pump and the other two heating systems that we just talked about is that heat pumps move heat from one area to another, in this case from the outdoor air to the indoor air, as opposed to generate heat through the use of an energy source. And because of this, they are very, very efficient with the use of their energy in providing the heat that we need for our homes. In some cases and in some climates, as much as 3 to 4 times more efficient than even the most efficient gas furnaces and electric baseboards that you would find in the homes of yesteryear. There are also geothermal systems available, which you may hear about in more advanced new construction or where there is an appropriate site for construction that has a ground makeup that is compatible with a geothermal system. Geothermal systems involve running loops of pipe down into the ground to harvest the ground source heat that is below us at all times. Even as the air around us changes temperature through the seasons, the ground below us, once you get about 3 to 4 feet down, is very stable in its temperature. And depending on where you are in Canada, that can be above zero for the entire calendar year. And so geothermal systems are able to tap into that warmer temperature in the soil and use it with heat pump technology to move the heat out of the ground and into the home. One of the things to keep in mind with all of these systems, but with heat pumps in particular, is that having them right-sized for your home is perhaps one of the most important aspects of what we're doing. What do I mean by right-sizing? Well, unlike conventional wisdom of years past, bigger is not always better. And what we want to make sure is that the demand for heat, or the call for heat that your home has, is matched by the output of the system that is providing that heat. The better that match, the better the system is going to operate. And not only will that provide longevity for your equipment and prevent early burnout of systems that are running on and off too frequently, but it will also help to really deliver on the promise of comfort that these systems come with. So make sure that as you get into projects of your own or you're working with a builder, ask about right sizing and what steps are being taken to make sure that it can be delivered for your project. Let's talk about the second of the systems, cooling systems. Cooling systems are not present in all homes. In fact, in many homes that are older in places like Vancouver and other locations in BC or even throughout Canada, it can be uncommon to find cooling systems in a home. When I say cooling system, many of you may immediately go to air conditioning systems, and you're not wrong to do that. Really, air conditioning has been the most dominant cooling system available in houses for a very long time. It's very frequently sold as an optional add-on in new home situations, and it is one of the most common mechanical system retrofits that we see on homes of certain generations, where the home buyers, after living in the home for some summers, may decide to add an air conditioning system to their existing heating system to provide more summer comfort and control of humidity in our humid climate. It is less critical to the durability and resilience of the home to have these cooling systems in place. And in fact, the addition of a cooling system does place a new energy load on the house, meaning that your home will consume more energy if you have a cooling system running through the summer months. But with the advent of heat pump technology, which we've already talked about, we have a new opportunity to provide cooling and heating systems in one package that can be very, very efficient and can support backup systems that use whatever energy source we prefer. As we find the summers in Vancouver and throughout Canada are getting hotter and hotter and are more exposed to extreme climate events like heat domes or sustained periods of very warm weather, it can be very important to consider a cooling system for your home solution to provide both protection for you and your family and comfort, and to think about doing it in the most energy efficient way that you can. The third system that is very important to consider in houses is the ventilation system. Ventilation refers to the exchange of air so that the stale air in our homes doesn't build up and can be exchanged for fresh air that we need to breathe and to live healthy lives. You can think of ventilation systems as the lungs of a home. And I like to think of it as, I often talk to people and say, how important is a ventilation system? Well, how frequently would you like to breathe fresh air? And if your answer is, well, I would always like to breathe fresh air, then a ventilation system is the piece of equipment that is going to serve that need for you. In older homes, it may be very uncommon to find ventilation systems. In fact, they weren't common in codes until we started to require air tightness in homes and move towards energy efficiency and building resilience with air tightness. That's when we started to really raise awareness that ventilation needed to be added to homes to provide the fresh air that occupants need. It can be crucial in Vancouver's humid climate to provide the appropriate type of ventilation. And ideally in homes that are of a newer vintage or that are being upgraded with better air tightness, it's important to consider balanced ventilation to provide an exchange of air and a recovery of energy. And we'll talk about that technology in a bit more detail when we talk about when it's appropriate to move towards a balanced system with heat recovery, and when it might be okay to stick with older systems of ventilation, such as exhaust fans or bathroom fans that run on a central switch. Terms that you might hear in reference to ventilation systems include HRV and ERV, which are two types of balanced ventilation systems that improve air quality and minimize energy loss by recovering the heat and, in some cases, the humidity of the air that is being exhausted from the house and putting it back into the fresh air that's coming into the house without cross-contamination between the two air streams. HRV stands for heat recovery ventilator, and ERV stands for energy recovery ventilator. And the biggest difference between the two is that ERVs will recover some of the humidity of the outgoing air and put it back into the air as well. Now, the use cases for each do vary. In arid climates where it's drier, ERVs are often preferred because they will help to maintain the humidity that is in the home, which is a desirable thing. In some more humid climates, a builder or homeowner may prefer an HRV, which allows them an opportunity to dry the air by ventilating and exhausting that extra humidity out of the air. However, in cases where we pair a good ventilation system with a good cooling or dehumidification system, like an air source heat pump in summer or a high efficiency air conditioner, then ERVs may make sense in those cases as well. Last but not least, let's talk about the hot water systems of our homes, which are the fourth part of our mechanical systems. Hot water systems are somewhat unique because, unlike the past three systems that we mentioned, these are not particularly focused in most cases on conditioning the air inside the home, but rather to provide hot water for cooking, washing, bathing, etc. It's very common for us to be familiar with the hot water system in our home. All homes will have one, and typically we would find in older homes that this would be either a storage tank of some kind, usually powered by either natural gas or electricity. But more and more we are starting to see higher efficiency options in newer homes or in retrofit cases, such as tankless or instantaneous water heaters, which you can recognize because they're much smaller and they tend to be wall hung and look like a box rather than a big tank. But also there is a new technology coming to market quite quickly, which is called heat pump water heaters. And for those of you that have been following along so far, you may recognize that we've talked about heat pumps already in the context of cooling and heating for the air in our home. Well, the same technology can be used to heat water in our water tanks as well, with some of the same benefits of efficiency overall. So we'll explore whether or not moving towards a heat pump water heater or a more efficient gas water heater in your home makes sense when we get to the renovation part of this masterclass. Now that we've introduced the main components of a mechanical system, it's important that we take a step backwards and talk about something called building science, or what is sometimes referred to as house as a system thinking. A home is typically consisted of components that fall into one of two main categories, either passive systems or active systems. Now, I've already referred to active systems as the parts of our homes that use energy or fuel to perform a service for us. And really, that's what mechanical systems are. They're very firmly entrenched in the active category of our home. So, what is the opposite of that? What is a passive system for our home? A passive system can be thought of as all of the parts of the home that make up the building envelope that separates us inside the home from the environmental conditions that are outside of the home. And these can include the walls, floors, and ceilings of the home, the windows, how airtight all of these components are when put together, and the insulation levels that are a part of our walls and ceilings and floors, or the insulation values of our windows. And these are referred to as passive systems because once installed in the home and once the home is built, they continue to perform their duty without any energy input for the lifespan of the home, or at least of the product in the case of windows, which sometimes will need replacing at a certain stage in a house's life. What's really important to recognize, and why I feel it's important to take a step back and talk about building science in this context, is that the active systems that we put into homes respond to and influence the passive systems in the house already. To put it in a more simple way, if the building envelope that we are surrounded with can keep the indoor and outdoor conditions better separated, then the demands on our active systems can be reduced. And the smaller those demands are, the smaller the heating demand or the cooling demand, the more efficiently the systems that we put into our homes can serve those needs. We've talked about the systems that make up that active side, being space conditioning. When I say space conditioning, that's the heating and cooling that we talked about, ventilation, and even hot water. And these interact with that passive building envelope to define a budget that must be met with our active systems, a budget of heating need, a budget of cooling need that we have to meet with these systems. In my work at Building Knowledge, when we're helping builders look at a new house design, for example, or even a renovation project, we frequently refer to house as a system as a pyramid of opportunity, would be the way I like to put it. And in the building science pyramid, passive systems form the foundation. And that's because if you have an opportunity at the start of a house's life to do them properly, they can last the entire life of the home and not need upgrading down the road. In existing homes, unfortunately, building envelope upgrades can be more of a challenge and frequently come with a higher cost. But in deep retrofits or substantial renovations, there is still an excellent opportunity to look at what building envelope upgrades can be accommodated so that you can consider those before moving on to the second tier of the pyramid, which would be the active systems of the home. And we say that that's the second tier of the pyramid because it is designed to meet the conditions established by the foundation. In a renovation situation, we may be assessing that foundation more than designing it, but the interaction of the two systems is still basically the same. Something that we won't get into in this masterclass, but I'll mention here since we're talking about the building science pyramid, is the tip of the pyramid is typically reserved for renewable systems. And this means the parts that you can add on to a home at any stage of its lifespan, like PV or solar panels, as we commonly refer to them, that can actually generate energy and give back to the energy balance of the home or provide energy to the services that might need them in times of power outage or grid failure, etc. They're at the top of the pyramid because they tend to be the most expensive component and are only sensible to look to once you've really got a good handle on a right-sized mechanical system and a good building science foundation on a passive system foundation. Let's start today by talking about newer homes. Now, what is a newer home in our definition of this? Let's talk about two subcategories of new home for a moment. In the first case, A truly new home is one that is being built for you. Maybe you're shopping for a house with a builder or developer, and the home is not yet constructed. And there are a different set of opportunities related to mechanical systems that exist when the house is just a drawing on paper still. But there is still a category of new homes, which are houses that have been built in the last 20, even 30 years, that still exhibit many modern approaches to energy efficiency and compliance with more stringent building codes that we would classify as a newer home because of the differences that it'll show in what has been put into that home compared to homes that are even older than that. So let's talk about the first one. A home that is still on paper that you are working with a builder to design really allows you to ask questions about that building science pyramid that we referred to in a previous chapter. While you may be working with the builder to balance considerations of budget and scope and design all at the same time, asking questions about the building envelope, how insulation levels are being considered, what quality of windows are going into the home, and then how the mechanical systems are being designed to react to all of those is an important question that you can ask to at least have a conversation and make sure that the builder is pursuing a good practice in these spaces. A very important team member in this process, and one that many builders in Vancouver and BC are already deeply familiar with, is an energy advisor. An energy advisor's role is to bring a knowledge of house as a system thinking to the process of designing a home and to help make sure that the right questions and considerations are given when we are trying to match passive and active systems for the best possible performance for the end user, which is you as the homeowner. In newer homes and in homes that are being built today, you have an opportunity to look at the most efficient systems that are available. And so we frequently see in today's building climate that solutions for new homes are some form of air source heat pump, which might be matched with either an electric or a natural gas backup or supplementary heating system. And what that means is you have a system that is served by two pieces of equipment, in this case, a heating system or a heating and cooling system that is served by both your air source heat pump on one hand and your backup system to supplement that when the heating demands exceed what the heat pump can really do. Now, sizing a heat pump for proper operation is a very complex topic, and one that I will suggest is best left to the consultants and the energy advisors to dive into. I will highlight that it's very important that they do that. And as a homeowner, it can be a big lift to try and understand heat pump curves and how they're matched to heating loads. Suffice it to say that if you ask the question, are you looking at properly sizing the heat pump system? That may trigger at least some reassurance from your team that this is being considered. Let's talk for a second about the other category of newer homes, which would be homes that already have been built. And you may be looking at a pre-owned home or maybe one that's already been built in inventory and you're taking it as it is. Well, what can you look for in a new home? I think when we're looking at new homes, typically we're not considering major renovations because many of the components of a newer home are still well within their operating lifespan. And trying to replace them when they're only 5, 10 years old in the home can be a little bit, unnecessary, especially in the case of windows, for example, or siding, which would be an opportunity for extra insulation, but wasteful if we have to tear off all the new siding and throw it out before it's reached its lifespan. So in homes of this vintage, you're typically dealing with better windows. Our codes have required good windows for several decades now. Usually good levels of insulation in homes that are 10, 20, 30 years old. Always some opportunities to improve those in places like attics that we can get to very easily. But really what I'm trying to say is that homes that are new-ish tend to have a better quality building envelope. That foundation of your pyramid is going to be slightly better, more stable, and the opportunity for the mechanical system to operate in its most optimal way is really already established. Now, depending on how new your homes are, you may or may not see things like air source heat pumps in an already built new home. But what will be very common is furnaces. Natural gas furnaces are very typical of homes of this generation, and still natural gas and electric hot water heating systems to serve that load there as well. It may be more common to find ventilation systems in homes of this vintage. Maybe not an HRV per se, but at least an exhaust fan that operates as a ventilation system. You can usually recognize this in a home if there's a light switch beside the thermostat that says fan or something similar on that. And in some homes, when you flick that light switch, you'll notice one of the bathroom fans goes on and off. And really what that means is that that fan was designed as your primary ventilation system and should be left on as much as possible to provide the air exchanges that your home needs. Now, in a newer home, you may not be too keen to rip out a furnace that's operating just fine and replace it with something else. But there's a really great opportunity with heat pumps nowadays to add them onto existing mechanical systems to augment their performance even more. And the reason this works so well is that, as I mentioned in the introduction today, heat pumps are like air conditioners, very much the same technology, except that they operate both to heat and to cool. And because it's so common for us to understand that adding air conditioning onto a house is something we can do, the same logic applies to heat pumps, and we can take the same comfort in knowing that adding a heat pump on will operate very much the same way. Now, for those of you who've never seen a heat pump before, you may be wondering, well, what do these things look like? Is this going to be a totally new thing on my house that I don't recognize? I don't understand what it's for. Well, to the untrained eye, a heat pump and an air conditioner are indistinguishable one from the next. They both look like a compressor outside of the home. The modern ones are very quiet and operate at very high efficiencies. And all that's needed to tie it into an existing system is the same set of line set pipes or coolant pipes that go through the wall of the house and into the ductwork before or after your furnace, depending on what type of furnace you have, whether it's electric or gas. And so there is still an opportunity, even with a newer home, to look at improving the efficiency of our systems with this new technology without having to tear out equipment that is still well within its operating lifespan, which is also a good practice just from an efficiency of materials and carbon waste in our practices in building homes. With hot water, again, we're typically dealing with newer homes with equipment that is well within its life cycle. And so you may want to look at opportunities for improving the heating and cooling system first. But where you're looking at replacing the hot water solution, especially if you're in a smaller home or a home maybe that is an attached home, I'm referring in that case to like a townhouse, a semi-detached home, even an apartment. Sometimes a heating cooling upgrade is less effective than a hot water upgrade. Let me explain that for a second. In a new home that is attached to its neighbor, the surface area of the home that we can lose heat through is much smaller than on a home that is detached from its neighbors. And because of that, the heating load is actually much less. And you remember I talked about heating loads as what the building envelope defines for us and what our active systems have to satisfy. And if we already have quite a low heating load, we actually, if we can imagine a pie chart of where the energy in our houses go, for attached homes, the hot water energy use is actually a bigger piece of the pie sometimes than even the heating energy use in new homes. And so in those cases, if you are motivated by saving energy, perhaps on reducing utility costs, and you have a home with very little exposed wall, maybe it has very good windows, then you may want to consider a hot water upgrade first. And as I mentioned before, some of the systems available for that include high efficiency natural gas, which can move you from, an efficiency of a tank might be only 60 to 70% efficient. The top performing instantaneous gas heaters now are 96 to 98% efficient. And if you move into electric heat pump technology, you can even go to 250 to 300% efficient, turning electrical energy into hot water for your use in the house. Finally, with newer homes, ventilation, as I mentioned, is very important. One of the most important things that you can do to determine whether or not your ventilation is adequate in a home you're considering purchasing is either ask for the energy audit and blower door test that was done, or ask that one be performed if it hasn't already been done. If you haven't heard the word blower door test before, you will start to hear it more and more as we move forward with our energy codes. But a blower door test is a simple test that an energy advisor can do on a house to determine how much leakage there is through the walls and windows and ceilings, all the components of the building envelope, and how much that air leakage may be contributing to uh, really that isolation of air from inside and outside, and the need for a proper ventilation system to compensate that. One of the myths that I've taken it to heart to dispel is the concept that a house can be too airtight. And really, I think the important rephrasing of that idea is that there is no such thing as a house that is too airtight. There is only a house that is underventilated. And so strive for airtightness in homes and look for these results in a new home if you're asking about them. But make sure that the ventilation system that comes with that new house can respond to that need, respond to that demand for fresh air, to be the lungs of your new home. Older homes, on the other hand, often have outdated mechanical systems that may be ready for replacement or upgrade, which is an opportunity that you have when you're looking at homes of these vintages. Now, when I say older homes, again, there are many eras of housing, and all of them have unique characteristics, different trends, different design aspects, and different levels of, for example, insulation that you may find in them. The most useful starting point, as I mentioned before, may be to start with an energy audit done by an energy advisor, which can really outline the condition of the home as it's found and highlight the first opportunities for most impact when it comes to updates that you may be considering making. However, there is kind of a turning point, typically if we think of mid-century homes as homes that might be from 1950 to 1980 and 1990 even, versus homes that were truly older homes before that, pre-1950, as noticing the presence or absence of insulation in those two main things. Older homes, pre-1950s homes, may have no insulation at all, or if they have any, it was probably installed to protect pipes from freezing more than to protect occupants from freezing, or to prevent energy efficiency wastage in the homes. So in cases where there is no insulation at all, mechanical systems have to serve a much bigger load, and the opportunities for getting complexity and really refined operation can be hampered by that lack of quality in the building envelope. So not to discourage you, sometimes an older home is the best choice because it's still standing after 100 years. That's something we can all aspire to. And I think that older homes as well might have heritage character or be part of an existing fabric in a neighborhood that are important to recognize. And so when I point out that the building envelope might be lacking, that's not to say that we can't still look at new furnaces, new heat pumps, new hot water systems to serve the loads in that home. We may just find that those systems have to be bigger and therefore slightly more expensive than the equivalent system in a home with a better building envelope or a newer home. Sometimes we might find in an older home that these systems have already been updated out of necessity. For example, furnaces typically have a lifespan of 20 to 30 to 40 years, depending on how well they're matched to their heating loads and how they're operated by the homeowners. And frequently, if you're buying a home from the 1950s, it may have already gone through one or more system replacements, both for heating and for hot water. And so in assessing an older home, you might ask when that replacement was done. And if the information is available, even what are the specifications of the new equipment? Have they upgraded it with whatever was cheapest off the shelf at the time? Or was the energy efficiency of that new piece of equipment a consideration when it went in? We've seen over the years, over the last 4 or 5 decades especially, that furnaces as an example case have really excelled in their efficiency compared to what they used to be. An older furnace from the 1970s, 1960s, if it's still running in a house, is probably only operating at 55 to 65% efficiency, whereas the requirements for today's furnaces are essentially 95% efficient and above. And so asking when the furnace was put in might give you some clues as to whether you're dealing with something that's 70% efficient, 80% efficient, 100% efficient, etc. Side note on what I mean by efficiency in furnaces, and in all appliances really. You might hear me using the term efficiency quite a bit today. And the term efficiency really refers to how much energy you have to put into a thing for the amount of energy that you are asking for it to output. And so if I put in 1 unit of energy, be that a cubic meter of natural gas or a kilowatt hour of electricity, and I get 0.7 of the same out, then that would be a 70% efficient system. What's really hard to wrap your head around these days, but is very exciting in this space, is when we look at systems like heat pump systems that are more than 100% efficient. And you might be asking how that is even possible. And it's because of their ability to move energy rather than transform energy that you really see that efficiency level can be achieved. It's important to note here as well that there is a lot of conversation out there about the carbon impact of our choices here and how we're going to move forward with our houses. And flexibility and resilience and cost of fuel and decarbonization of the grid are all big ideas that we're wrapping our heads around in this space. And I encourage you to think on them and find what you can. Might be a topic for another masterclass. But with all of these mechanical systems, you have choice. You know, there are electric and gas furnaces, there are electric and gas air source heat pumps, hot water tanks, etc. Pretty much the only one that runs strictly on electricity is the ventilation systems that are available these days. But depending on your market and your need and what utilities are served in your area, you may look at flexible options to satisfy any one of these replacements in an older home. Similarly, in an older home, you may have air conditioning that's already been retrofitted by a previous owner. And when we mentioned right sizing before, I think it was leading up to this comment that older homes that have AC added may or may not have done so with any consideration for sizing. There are a lot of rules of thumb that we use in renovation projects and in equipment retrofit projects, or I shouldn't say I should say have been used for years. By people who are doing their best and well-intentioned, but maybe don't have access to proper heat load, heat gain calculations. And so sometimes the air conditioner that is on the house may be oversized for the house's needs itself. And we'll talk about why that matters more when we get into the real sequencing of renovation and why you might consider doing a heat load calculation for an upgrade to a heat pump, for example. Another issue or challenge, I should say, prefer to think of it as a challenge than an issue, but an opportunity challenge, if you will, in older homes, is that they may suffer from poor air quality because of a lack of a ventilation system. And a ventilation system, whether that's a balanced heat recovery ventilation system, an HRV, for example, or just an exhaust fan with a supply air. A supply air means a fresh air intake that's going to be connected to your furnace ductwork. This addition in an older home can really make a difference in dealing with condensation, issues of mold, and general issues of poor air quality. The air quality issues may also be related to poor air tightness, which can contribute in a big way to drawing air in through, for example, a really damp or dusty basement or crawl space before it makes its way into the house. And also older homes with older equipment might tend to have what's called open combustion appliances. What does that mean? Well, an open combustion appliance would be a hot water tank, even a furnace, or some other heating device that burns a fuel without proper closed systems for removing the contaminated combustion air from the house. They may have an open chimney or flue that tries to deal with that contaminated air, but may or may not capture all of it depending on the vintage of the home. And so as you look at ventilation solutions, it goes really closely hand in hand with looking at whether the home can be improved from an air tightness perspective, and maybe an opportunity in the mechanical systems to look at what are called closed combustion appliances. I will reassure you that modern appliances, modern hot water tanks and furnaces that are electric don't have any combustion fuel, so there's no issue there. And if they're gas, all of the modern ones have either a dual pipe or some other form of closed combustion, meaning that the air that they use to burn comes directly from outside, and after the combustion happens, all of the exhaust goes directly outside as well and never interacts with the other air inside the house. In terms of hot water systems in older homes, same sort of opportunities are there, or the same sorts of things might be observed. Conventional water tanks may be very inefficient, but may have survived a very long time in an older house. And typically, we would see that these systems aren't replaced unless they have failed in the past. So they may be original to the house, and they may be operating at a very inefficient level. So there are things that we can do to help hot water tanks in older homes. If the tank is still working, we don't want to replace it. It's possible to insulate a tank, for example, by wrapping it with an insulated blanket. And this allows it to reduce its heat loss and therefore consume less energy for whatever lifespan it has left. But if you do get to a point of saying, well, the hot water load is now my biggest load, or maybe it's an opportunity that I would like to capitalize on, maybe there is an incentive program available, which are widely available nowadays for more efficient equipment in general, then I can capitalize on that opportunity to upgrade that tank to a more efficient heat pump water tank or high efficiency gas tank. So to summarize the vintages of homes that we've touched on, the ones that might really benefit most from a building envelope improvement first are the older homes that we see. So if you do have a home from pre-1950s that you're looking at buying or maybe making some improvements to, have a look at your windows, have a look at your attic. Consider if you're doing a deep renovation or really a gut reno, as we might refer to them, whether you can improve the envelope of the house first. That may be the biggest opportunity that you have in homes of that vintage. But as we get to homes that are slightly newer, from the 1950s, 1980s, what we might refer to as mid-century homes with some insulation, maybe slightly better windows, then really there might be an opportunity to look at the mechanical systems as a good starting point for making big savings in the gas use or electricity use of the home. Again, with all of these types of projects, whether you're working with a builder or you're doing it on your own, working with an energy advisor is going to give you insight into how these improvements will affect your energy use and your comfort. And if your energy advisor is well versed in building science, and I advise that you ask the question, then they can really help you balance these systems and make sure that they're not working against each other, but rather that they're working in conjunction with each other to make sure that the house is preserved for a very long time. I hope you've taken away from this masterclass the important message that mechanical systems and the building envelope of your home, which you'll recall as the windows, the walls, the floors, and anywhere where we've got insulation, that these two components work together to operate in a house as a system way. That is to say that the mechanical systems respond to the passive systems in the home and vice versa. And when properly balanced and aligned with each other in a good working relationship, they will provide better comfort, better durability for your home over time as they manage things like humidity and moisture in your walls, better energy efficiency, and an overall more resilient home, which you can rely on for a very long time to come. Whether you're looking at buying a new home and making some small improvements, buying an older home and making some major improvements, or really anywhere on the spectrum between those two extremes, it can be very beneficial to engage with an energy advisor or to work with a builder that already has a good relationship with an energy advisor to help guide the upgrades that you can make to maximize that benefit for comfort and energy efficiency. And I do want to emphasize the comfort component here, because ultimately our ask of mechanical systems is that they provide comfort for us, right? We don't sit in a cold house because it's not comfortable. And what I've found over my years as an energy advisor is that if we think of comfort and we do it with an appropriate approach that balances the building envelope and the mechanical systems, then energy efficiency follows, and in fact is often the result. And it's a little bit of a flip in thinking that we've come to nowadays, where we used to think about energy efficiency would deliver comfort, and now we're realizing that comfort can deliver energy efficiency when done properly. So think about these things as you're considering upgrades to your mechanical systems, that it's not just about saving energy, it's not just about trying to save a few dollars on the electricity and gas bills every month, but it's also about optimizing comfort in your homes and making sure that you're using the best possible systems and the best possible sizing practices to achieve that end. One thing that I'll leave you with when it comes to mechanical systems, especially forced air systems or any system with a ductwork attached to it, is that maintenance by the homeowner is an important takeaway, an important consideration. These systems are operating day in and day out with no rest to try and keep up with our demands in the house. And one of the most important things that those active air systems have to help them run for a long time is a filter. Now, this might sound like your parents harping on you for something that you forgot to do as a teenager, but change your filters. It's very important. As filters get clogged up with debris and dust from inside the house, they can reduce the efficiency of your system and really slow down the air filtering process, the amount of air delivery that your system is trying to give you to make sure that your needs are met. So don't forget to change them. Make sure you change them with the appropriate size so that you have a good fit in your filter slot all the time. And make sure that you're looking at the manuals that come with your equipment to choose an appropriate MERV rating. A MERV rating is the fineness of a filter, the maximum size of particle that can fit through it. And we might have an instinct to, again, take that approach that a higher MERV rating is better, but we need to make sure that the equipment we're putting it in front of can handle that resistance. So learn the controls to your systems, take the time to ask the questions from your builder or your installer. Remember to change your filters, and I think you'll enjoy a good mechanical system operation for many, many years to come. I hope this masterclass has provided you with some important knowledge to help you make better decisions around your home buy experience or your home building experience. Don't forget that it's a complicated space and it's okay to ask questions. And as you look at mechanical systems in older homes versus newer homes, and you start to see the differences, I hope that you'll take something from this course with you that is helpful. Thank you for joining me today for this masterclass. I hope that you've enjoyed it and you've taken away some new learning. If you have an interest in more resources or more learnings, then you can check out all of the links below.